Hello, my name is Les Murray, and I'm a NASA Solar System Ambassador. And I'd like to talk to you today about the upcoming eclipse on April the 8th and share a few details there. The first thing I'd like to talk about is the actual NASA Solar System Ambassador program. And we are volunteers. We don't work for NASA, but we're volunteers that are dedicated to science education and NASA outreach. It's been a program that's been ongoing since 1997. It's sponsored by NASA JPL, the Jet Propulsion Laboratory. And our goals are to inform people about the ongoing NASA missions, uh, interesting things that are going on in science right now. Um, Also to let people know about all the great educational resources that NASA has available, um, and STEM outreach. And they do train us. So every week or two, we have a session where they will give us training, and they'll actually let us meet the project leads, um, the scientists, the mission scientists, sometimes astronauts, and they'll actually give us real in-depth information about what's going on at NASA and the science and the programs. And we take them out to libraries, museums, other places, schools, and we're a resource for you. So invite us out if you'd like to have us come out and give a talk. If you look down there, there is an address for the Solar System Ambassadors Directory. So it's map-based, so you can find one in your area, and they can come out and give a talk or help you plan an activity or help you find all those great NASA resources that you can use in your classroom. You can also contact me at my website, www.skyambassador.com. So the things that we're going to talk about today are what types of eclipses there are, some info about the upcoming eclipse, safety, because you really need to be safe during the eclipse, things that you might want to observe during the eclipse. There's a bunch of events that are going to happen during the eclipse, and some interesting effects that you might want to observe. So we're going to talk about those. And lastly, we'll give a little bit of a history of things that occurred, or science that was done during eclipses. So first, there's three types of eclipses. There's partial solar eclipses, annular solar eclipses, and total solar eclipses. So the partial solar eclipses, let's talk about that first. So partial solar eclipses are eclipses that are observing when you're out of the path of totality. So if you look down in the picture down there, you'll see a blue line and a red line, and those are the extents or the area that is actually in totality. Outside of that, you won't be in totality, and the moon won't line up with the sun and therefore won't cover it. And so in those use cases, what you'll see is kind of like the picture on the upper right, and you'll see the sun, but only partially obscured by the moon. So as an example, in the 2017 total solar eclipse, I was in St. Louis, and for me there it was a total solar eclipse, but here in Dallas it was only about 80%. So for that date in Dallas, it was a partial solar eclipse. So that green line in the middle is totality, and that's a line of totality. So this and the distance from that green center line determines the duration of the eclipse for you. So let's talk about another thing that can happen. So if we look here, this is actually a movie that was taken by NASA's Perseverance rover, and it's an eclipse on Mars. And so I don't know whether this is Phobos or Deimos, one of the two moons of Mars, but you'll notice that it doesn't cover the sun completely because that moon wasn't big enough um, to actually cover up the sun. And so that brings us to the next type of eclipse that can occur, and that's an annular eclipse. So with an annular eclipse, the moon and the sun are aligned. So in other circumstances, it would be a total eclipse, but the moon's not at perigee. So a couple of important points in the moon's orbit or any or thing orbiting the Earth is perigee and apogee. So perigee is the lowest point in the orbit where it's closest to the Earth, and apogee is the highest point or the furthest distance from the Earth. And so when it's at perigee, the moon appears bigger because it's closer, and at apogee, it appears smaller because it's farther away. And so if you have a solar eclipse and the moon is uh, at apogee, it'll be smaller, won't cover the entire surface of the sun, and therefore you'll get this ring-like effect, an annular eclipse. So that's what we had in October of last year. We had an annular solar eclipse, and so it didn't cover the sun completely. The bad part about both a partial eclipse and an annular solar eclipse is that during the whole duration of that eclipse, you can't take off your eclipse glasses. So there's no period of totality, and that's the only time you can take off your glasses. So this little animation will kind of show that difference in size between perigee and apogee, and it does make a big difference for eclipses. Then the third type of eclipse is the total eclipse, the type that we're having on April the 8th. And that's when the moon and the sun are totally aligned. The moon is at perigee, making it larger so that it covers the entire sun. And when that happens, you can actually see the corona of the sun. So you can kind of see it in this picture, but it doesn't really do it justice. When you reach totality in a total eclipse, the corona will just pop out from the sun, and it's really quite large. I always say it looks like a lion's mane because suddenly the sun, when you hit totality, that corona will pop out, and you can see it really, really far away from the sun. Additionally, you'll see these little pink areas, and those are areas where coronal mass ejections are occurring. I have solar telescopes, and when I look at the sun, I can see those CMEs all the time. Almost every day, there's ones all around the sun that you can see. But the great thing about a total solar eclipse is that you can actually see those naked eye. And so, it'll be a real treat to be able to see that for yourself, naked eye. So this is a map of the path of totality, and the path of totality is stretching all the way across the US and up into Canada. And you can get this map at the NASA website and download it, and it'll give you a good idea of where it's passing all across the United States. So a little information about the upcoming eclipse. So it's on April 8th, and it begins around 12:20 and ends around 2 p.m. It varies a bit from place to place. This is in Central Time Zone. And the thing to remember about the eclipse is you can only remove your glasses during in the total eclipse during totality for it's about 2.5 hours or so for the total time of the eclipse, but totality will only occur for about 2 to 3 minutes, upwards to almost 4 minutes in some places in the DFW area. At all other times, you got to keep those glasses on because it's never safe to look at the sun directly at any time, and especially at the eclipse. And if you'd like to calculate how long the eclipse is going to be and look for good places to observe the eclipse, hopefully you already have that place picked out, but there are some tools that can help you find a good place. One of them that I like is the National Solar Observatory Eclipse Calculator and also the Naval Observatory Eclipse Calculator. Um, we'll take a look at the National Solar Observatory Eclipse Calculator, that one at the top, and it's a really good tool. So this is that tool. It's just a web tool, and so you can see here we can look all along the path of totality. We'll kind of look around the DFW area. You can scroll in and scroll out so that you can look at different places around the DFW area. And so, for example, as you get closer to this green line, you maximize the time of totality. So, for example, you can see almost 4 minutes and 21 seconds here along the green line. And as you move outward towards the blue line, the time is going to get progressively less. In this example, about 2 minutes and 39 seconds. Um, you know, and as we get to the edge, um, you know, you can see the time. So what you want is you want to be in the path of totality, which means between the red and blue lines, and as close as you can manage to the green line, and that'll maximize the time of eclipse. Um, but this is a really great tool for picking a good spot. Um, and just to give an example, I'll actually be in the Colony, Texas, and so you can see for me, it's about totality is somewhere between 2 minutes and 24 seconds, um, all the way up to like 2 minutes and 40 seconds, somewhere in the neighborhood. So the these are just a few calculations for cities that I'm helping. So eclipse safety. So only look through solar glasses is my recommendation. Um, they need to be ISO certified. ISO is the International Standards Organization, and ISO 12312-2 is the safety standard for the solar glasses. So you want to make sure that any glasses or filters that you buy actually have that on them. You can also observe through solar telescopes, which I have one that are specifically designed for looking at the sun, or through a normal nighttime telescope if you have the correct type of filter. And so I have several telescopes that I have a filter, a solar filter, that is designed very specifically for looking at the sun and observing the sun through them. You can also use welder's glass, number 14 or above. I know some places on the internet they say number 12, and number 12 is okay, but NASA recommends 14, and also the contrast is better. I still would recommend that, the solar eclipse glasses are pretty cheap. They're specifically designed for this task. One of the other things is do not use normal sunglasses. There are no sunglasses that can be used safely to view the sun, uh, either during the eclipse or even, just normally. So you don't want to use sunglasses. Um, using solar eclipse glasses, or they have these little cards, which are solar eclipse viewers. Those are great. Um, it is not safe to look through your camera at the eclipse, except for during totality. It is not safe to look through binoculars. That would be concentrating the light and would definitely do damage to your eyes. You shouldn't look at all, but um, without some type of protection. But for certain, any of these would certainly make it a lot worse. Looking through a telescope, once again, would concentrate the light and damage your eyes. It's also not a good idea to try to observe it just directly with your phone. Um, it that's a lot of light pouring into that phone and isn't the greatest on your phone itself. But if you want to safely view it, things that you can do is you can buy a filter for your camera so that you can take pictures of the sun. You can buy filters for binoculars or a telescope. Additionally, if you want to observe the eclipse uh, with your phone, you can also use a piece off of one of the glasses to protect the camera on your phone, and then you can take pictures of the eclipse. One of the other things to note is in all these cases, the filter is on the front of the device because you want to block out the light um, at the beginning of any optical train that you have because it's not really safe to try. There are some filters that I've seen, for example, like for telescope eyepieces. Those are not a good idea because you want to block out the light before it gets concentrated by the telescope or any other device. And so, that's why you always want a front filter. It's also something to note that your camera, if you have a reflex camera, when you look through the viewfinder, you're actually going to be looking, directly at the eclipse unless you have the filter on. So just make sure that you have the filter on in all those cases. Um, if you don't, one of the things that can happen is you can have solar retinopathy. And in fact, in some cases, you can actually see the image of the eclipse on the back of people's eyes that do have this. And what you get is blurry vision, a headache, a blind spot, um, increased sensitivity to light. You actually, straight lines look bent, door jambs look curvy, and it also can change your color perception. So that's something you don't want to happen. And so you really want to protect your vision. You also want to pay attention to the kids around you and make sure that they're not uh, observing the eclipse in an unsafe manner. And in today's world, you might want to be sure that the eclipse glasses that you're getting are actually really certified. And so one thing that can help with that is the American Astronomical Society has an approved vendors list, and they are a list of known ISO compliant glasses that they know have been tested and not just somebody who's printing it onto their glasses. So you can see https eclipseaas.org resources solar filters. That's the link that you would want to use to get to this list. And you can look at their latest list and buy from an approved vendor. So some of the things to look for during the eclipse. So one thing to look for is the shadow bands. Also looking for sharp shadows, Bailey's beads, the diamond ring, and totality. And also there are some things that you can observe during totality that are pretty cool. So first we'll talk about the shadow bands. These are shadows around the edge of the moon-sun boundary, and they're caused by atmospheric distortions. At least that's our best guess. They can occur up to 2 minutes before and after totality. Sometimes could be as little as 30 seconds before. They don't always happen, but in many cases they do. It's a phenomenon that's only been recently noticed and observed. And they can be observed wherever you have, for example, you can throw a white sheet on the ground and you could observe the shadow bands there. Um, a white wall is another place where you could observe these shadow bands. And they're kind of like snake-like shadows that kind of snake across the ground and that you can observe. So this is a video by Theory Powell's, and I'll show you a little bit of it. It's really hard to photograph but you can see it a little bit right here.
See? They all there. The flying shadow. Very slow.
Yeah, I got you.
But see? They all there.
So those are the kind of snake-like shadows that we were talking about. Another thing to observe is as you approach totality, um, there will be a small piece of the sun that is not covered, and most of it is covered, but you'll see this really bright contrast where the uncovered part is and most of it's covered, and it looks like a diamond ring. So if you look at the little bit around the edges that's kind of bright, and then the really bright portion on the top, it looks like a diamond ring. So look for that. Another thing to observe is Bailey's bead. So right before totality, so this is one kind of indicator that you're just right up on totality, um, is these uh, last little places where there are craters or valleys or irregular points on the surface of the moon. The sun will be peeking through them, and so you'll get these little kind of bright spots along the edge of the moon, and they look like, bright little beads of light that are on a string. And you can see the little bright line right here. And so that's Bailey's bead. So look for that. And also that's a great indicator that you're almost at totality and it's fixing to happen. So it's a good thing to watch for because it lets you know that it's fixing to happen. Then when you're in totality, the sun's totally covered. At this point, you can take your glasses off. You can observe it naked eye. It's one of the most amazing things that you'll ever see. Um, you'll be able to see the corona, hopefully some coronal mass ejections. Um, it'll get cool. The temperature will drop, maybe 10 degrees or so. It'll suddenly become almost like twilight. You should be able to see some of the brighter stars. It won't really get like nighttime, but you can observe some of the brighter planets and stars. Um, it often affects animals and insects. They're kind of confused by the sudden change, and it's really kind of a spooky feeling when it does occur. So, um, some things that you might want to be looking for. Um, so one thing is Venus. Venus is the brightest thing in the sky, and when totality occurs, if you look down and to the right of the sun moon eclipse, you should be able to see Venus. Should be bright. Then right below it is Neptune, but that's a telescopic object. You will not be able to see that. Um, This is also down below and to the right, you'll see Saturn. So that should definitely probably be observable. And just to the right of that is Mars. That may be observable. It's relatively dim, but Saturn's really bright. So you should be able to see at least Venus and Saturn. Saturn here and Mars here. And then if you have a really sharp eye, it's possible that you might be able to spot Mercury just above and to the left of the sun. And, you kind of have to know where to look, and it's, going to be a difficult thing to spot, but you might be able to spot that. A little bit further up and to the left, you might be able to spot Jupiter. I know this map also shows Uranus, but that's also a telescopic object. You won't be able to see it naked eye. And there's also a really fun treat is it might be possible to see a comet. So Comet Pons Brooks is going to be just to the right of Jupiter. And so comets are really hard to observe at nighttime. Um, they don't appear like they do in all the pictures that you've seen. They're basically little fuzzy blobs. But if you kind of know where to look and know what to look for, it's possible that you might be able to pick out that comet, which is really cool to be able to see a comet during the day. So, those are some things that when totality hits and it gets to be kind of twilight-like, you should immediately start looking for these things because you might be able to spot them. So let me turn off that cursor. Um, Another great way to see kind of what's going to happen and get a feel for all the steps and the pieces is Veritasium. That's Derek Mueller's channel. And he, in the 2017 eclipse, recorded basically a set of videos that gives you a feel for all the steps that we talked about, what's going to happen during the eclipse, and the excitement during totality that everybody has. And it's really a great video. I encourage you to go out there and watch it because it's really a great way to see what's going on.
17, they
So some other things that you might do during the eclipse, because there's about 2.5 hours where you're waiting, uh, or at least about half of that time you're waiting for the totality to occur, and you can use a colander, and a colander has very small round holes, and anything that has small round holes is going to act just like a pinhole camera. And if you project it onto a white sheet on the ground, you'll actually see an image of the eclipse for every hole in the colander. So, that's a great way to safely observe the the eclipse. Um, by the way, somebody asked me the other day if it was safe to observe eclipses in a pail of water. It is not. Um, I think there may be some angles where you could do that and it might be okay, but it's just not recommended uh, as being safe. There are much better ways, like the eclipse glasses to safely observe the eclipse. The colander is another one that's completely safe. Um, Also, one thing that you really should keep an eye out for is if you're underneath or near a tree, um, you can observe the where the leaves cross in the wind. It makes little pinholes, and those little pinholes will actually make images of the eclipse. You can see right here, my wife recorded a little movie of that happening on the October partial eclipse. So let's take a look at that. Or I'm sorry, the annular eclipse. So that's pretty cool. So keep an eye out for that. So now let's talk about some science that was learned from eclipses. So Hipparchus was around 150 BC, and he used eclipse observations to estimate the distance to the moon. And he got within 20% of the real number. And what happened was he noted that there was a total eclipse in Turkey, but it was only 80% in Alexandria, Egypt, which is about 1,000 miles away. He then used geometry to actually figure out the distance from the Earth to the moon. So, that's a great way in which eclipses helped us move science forward. Also, the discovery of helium. So, French astronomer Pierre Janssen, he got the idea of observing the spectrum of the sun during an eclipse. Normally, it's too bright to do this and too bright to get spectra. But during the eclipse, since the moon is covering up the sun, he can use that to get a spectra of the sun. So an interesting thing about helium is that, since helium is an inert gas, it doesn't really bind with anything. And so all the helium that was originally around the Earth was in the atmosphere. And since it's such a light element, it floated up to the top of the atmosphere. And long ago, was knocked off of the top of the atmosphere by the sun, by solar radiation pressure. And so there really was not any helium around. So we didn't have any idea that it existed. And when he looked, he saw a spectral line he hadn't seen before, and that was helium, because there is definitely helium in the sun. Nowadays, we get helium, we get it from mostly a byproduct of oil exploration. And since he observed that element and it was in the sun god's name is Helios, so he named the element helium. So there's another great science discovery that came from eclipses. So another thing was the proof of general relativity. So early this century, um, Einstein had put forth the theory of general relativity, which basically says that space and time is distorted by mass. So, something massive like the sun uh, will actually distort space-time. And when that happens, it actually bends light. So normally this is very difficult to observe because you can't observe near the sun. It's so bright that you can't make observations close to the sun. But during an eclipse, you can. So what they did is they took the known position of stars that were close to the sun during the eclipse. They measured them during the eclipse, and they looked for how much the light was bent. And it exactly followed uh, the predictions of general relativity. And that was the first time it had ever been measured and proved. It's been measured thousands and thousands of times since, and there have never been any disagreements with the theory of general relativity. So that's another great science discovery. So things to remember. So safety, safety, safety. Please protect your eyes. Please, um, you know, make sure that you have a good pair of solar glasses and don't take them off except during totality. Your location matters. So the duration of totality is wholly dependent on where you are. Timing matters, right? The, um, you know, 2.5 to 4 minutes total is the only amount of time there is totality out of that, 2.5 hour period. And so if you walk into the house at just the wrong time, you're going to miss it. And it's definitely something that you want to observe because it's a once in a lifetime thing. And most of us won't be around when the next one comes by this area. So just make sure you're very aware of the time and keeping track of it. Look for all the stages that we talked about and the interesting things to observe. Oh, also, I thought about one other thing. Um, During the eclipse, as you approach totality, just note the shadows because one of the things is shadows are kind of fuzzy normally because light's coming from a lot of places. But as you approach totality in the eclipse, the shadows will get really sharp because light's only coming from one direction and it's very parallel. So where you previously had kind of fuzzy shadows, you'll now have very sharp, crisp black shadows. So that's another thing to look at. So keep all these things in mind and look for all the things that we talked about. And I hope you have a great time during the eclipse.